Okay, so earlier today we have worked on trying to find the volume of a rectangular prism given 3 dimensions, right? And so in this video, we will be solving volume given an area of one of the surfaces of your rectangular prism and another dimension, okay? All right, so let's try to use let's pick this surface area, okay? The side area. In solving this area, you will need the width and the height of your prism, right? Since you are already using the width and the height of your prism, then you will need to get the volume, you will need the length. Okay, so remember, when we solve the volume, it's length times width times height, correct? So if we use the height or thickness and the width to solve your area, then that third dimension would be the length. Okay. Okay, let's try this with cubic units to make more sense to that. All right, so let's choose that side area. Okay. All right. In that side area, meaning the first column on the side, how do you get the area for that? Okay. The area for this one will just be your thickness times the width, right? So that is 2 times 4, which is 8. And that is for your first row on that side. If you notice the second row, meaning the one behind, the row behind your first row, if you scrape off the first row, you would still have an area of 8 because the thickness would still be 2 and the width would still be 4. And so it's the same thing with the third row. It would still be 8. The fourth row, the fifth row, and the sixth row, it'd still be 8. Okay. So what we're trying to do here is that we are trying to make sure that if you will pick the side area, then it's uniform area all the way, all along the length of your prism. Okay. And remember, when you try to solve for your rectangular prism, you always just to have to multiply your length times width times height. But in this case, we have one side area, which is the thickness times the height. And so we just have to multiply that area by your length. And length is basically just the number of is represented by the number of rows of uniform area. Okay, so therefore your volume is area times the length. Okay, and if you count all the cubes in here, you'll find out that there are 48 of them. Okay, so that's 8 in front, and then next there will be 8, another 8, so that will be 8 times 6, so you have 48. Okay, so another way of solving this one is, say for example, we use the front area. Okay, not earlier we used the side area and we multiply it with the length. Now here we use the front area, and the front area is solved by the height times the length, right? So therefore your other dimension would be the width. Okay, so let's try this example. Okay, in this one, this is your area, and the other dimension would be your width. The third dimension, or the other dimension that we are talking about here, is remember, you have 3 dimensions for your rectangular prism. Whatever you use for your area, let's say for example in this case we use thickness and height, so thickness, height and length, so therefore the third one would be your other dimension. Okay, if you use length and width, then the third dimension would be your height. Okay, all right, so our area here is 12. Why is it 12? Because the thickness is 2 and the length is 6. All right, and that would be the same for your first column area wise. So you have 12 square units. On the second column, you would also have 12. On the third column, you'll also have 12, and on the fourth column you also have 12. Okay, so in order for you to get the volume, it's just area times the width, and so that will be 12 times 4. If you notice from the previous slide, we also have 48. Okay, all right. Okay, so make sure you answer this one before you proceed on the next slide. Okay, so we'll be using the side area, which is 6 centimeters squared, and the length is 3 centimeters. So what is your volume? Okay, so remember, this is side area times the length. Okay, how about this one? This will be your front area times the width. All right, so um in this slide, I'd like you to really pay attention because your worksheet is related to this one. Okay, I want to find the volume of this. Well, obviously you can see that the volume here, you can easily count the cubes and find the volume, right? Or multiply all the dimensions. But part of the exercise here is to determine which, for you to determine a uniform area in the third dimension, okay? So for this one, we will use this as our uniform area, which is the front. This is the front area, right? And your front area is 2 times 3. So let's say 3 is your width. So this will be thickness times your width. So therefore, your other dimension will be the length, which is 4. Okay, so how do you get the area, the uniform area? When I say uniform area, that means the area on the front or on the side or bottom, whichever area you're using, is the same all throughout the third dimension. Okay, so for this one, we have 6. That's 2 times 3. And the length would be 4 because that's the third dimension. And your volume will just be area times length. Now, in rectangular prism, there are always 3 ways to solve this one. So I'd like you to think of 2 other ways to solve this one. Okay? 2 other ways to solve that. Meaning you need to use a different uniform area, you need to use a different third dimension, but the volume should be the same. All right? And so we have an assignment that comes with this video, and I'd like you to submit that on Wednesday.